What could cause an airplane to flip upside down during a crash landing? A Delta Airlines flight, having journeyed from Minneapolis, attempts to land in the snowy landscape of Toronto, but instead of a smooth touchdown, it crashes, flips upside down, and catches fire. Miraculously, all 80 passengers and crew members survive, although some sustain injuries. Now, the cause of this peculiar incident is under intense scrutiny by both Canadian and US authorities. While they work tirelessly to unearth the truth, we can take a speculative leap into the possible engineering and environmental factors that could have contributed to the flip. Could it have been an engineering anomaly? Perhaps the wrath of Mother Nature in the form of gusty winds and snow? Or maybe a human error? The answers aren't clear yet, but that's what makes it a mystery worth unraveling. So, let's dive into the world of aeronautics and physics to unravel this mystery. First, we need to understand the engineering aspects of an airplane. An airplane is an intricate marvel of engineering, designed to be aerodynamic and stable in the air. Two key components in its design are the center of gravity and the aerodynamics. The center of gravity is the point where the weight of the airplane is evenly dispersed in all directions. Picture it like a seesaw, where the balance point is the center of gravity. In an airplane, this balance point is carefully calculated and maintained to ensure stability in flight. Aerodynamics, on the other hand, is all about how air moves around the airplane. It's the science that allows a giant metal bird to lift off the ground and soar through the sky. An airplane's shape, its wings, and even its tail all contribute to its aerodynamics. Now, in a normal landing, the plane's weight is evenly distributed, and its aerodynamics are working to keep it stable and upright. But in a crash landing, all of this can change in an instant. An uneven weight distribution, or a sudden shift in weight, can throw off the center of gravity. This can cause the plane to tip or even flip over. Moreover, the impact of the crash can cause a rapid change in the airflow around the plane. This abrupt change can disrupt the aerodynamics, causing further instability. Therefore, the plane's design and weight distribution play crucial roles in its stability during a crash landing. Now let's talk about how weather conditions can affect an airplane. Crosswinds and snow, for instance, can significantly impact a plane's landing. Crosswinds, which are winds blowing across the direction of travel, can pose a real challenge. When a plane lands, it ideally wants to do so head-on into the wind for maximum control. However, crosswinds don't play by these rules and can blow the aircraft off its intended path. In extreme cases, a strong crosswind can tilt the plane. If the wind is forceful enough and the angle of the tilt is steep, it can cause the plane to flip during an emergency landing. This is a precarious situation, as it requires the pilot to counteract the wind's force to keep the plane aligned with the runway. Snow, on the other hand, brings about a different set of problems. A snow-covered runway reduces the friction between the plane's tires and the ground. This lack of friction can make it harder for the plane to slow down and stop, leading to a longer than expected landing roll. If the plane is already in an unstable position due to a challenging landing, this reduced friction can contribute to the plane flipping over. So, weather conditions can significantly impact the stability of a plane during a crash landing. Finally, we can't overlook the human factor in this equation. In the complex ballet of aviation, pilots play a crucial role, and sometimes a slight misstep can be magnified into a significant incident. For instance, an incorrect approach to landing or a late response to changing weather conditions could have contributed to the plane flipping. Even the most experienced pilots can be caught off guard by the unpredictability of nature or the quirks of engineering. Therefore, while machines and nature play their parts, human decisions can sometimes turn the tide. In conclusion, a multitude of factors can cause an airplane to flip during a crash landing. The very engineering of the airplane itself, which is designed to withstand a host of challenging conditions, can sometimes contribute to such incidents, particularly when met with extreme weather conditions. Powerful crosswinds and heavy snow, as experienced in Toronto, can significantly alter the plane's trajectory during landing. And let's not forget the human element. Pilot decision-making in critical moments can also play a role. These elements interact in complex, often unpredictable ways. Investigations into the recent Delta flight incident are ongoing and will hopefully shed light on the exact cause of the crash. While we can't control all these factors, understanding them can help us improve flight safety in the future.